Thanks, folks, for coming. My name is Mike Purvis. I work at Near Protocol in it's a company called Proximity. Oh, so sweet. And today we're going to be talking about some really amazing stuff. We're going to be talking about the hackathon, and we're also going to be talking about what this means kind of long-term. And so we're going to start with the title here, Ushering the Era of Bridgeless Cross-Chain DeFi, which is a whole bunch of words. And let's get started with the DeFi, and then I'm going to also set up the hackers to have some ideas about the best way to approach this. Okay, so it's finally out of that horrible bear market, it seems, maybe, hopefully. Let's take a little bit of a gander on what is happening right now in DeFi. And these are actually not even the most recent, but we are just seeing that finally activity is kind of picking up here. This is the bridge volume. Recently, we can see things picking up. Cross-chain swaps, also signs of life. This is wonderful to see for all of us who've been through this time. And, bridges are pretty amazing. I remember this was in DeFi summer, actually. Near Protocol launched the Rainbow Bridge, and this was August 2020. So this is right in the middle of all the action of DeFi summer, one of the most amazing periods in crypto. And basically what you need to know about bridges, if you want to, don't want to read this blog, although it's quite easy, you have a token on one chain, you lock it up, and then you mint it on another chain, and it's sort of an IOU, right? And this is the way that things have been working for quite a while. So, I think that Rainbow Bridge from Aurora is amazing. We have also, unfortunately, as everyone knows, we have seen a few different problems, and I'll be clear as we go through this is not a dunk. This is just sort of very, very smart people that build bridges, and unfortunately, there's been quite a few hacks. This seems to be happening over and over again, and I think as we just mature in this Web3 ecosystem, we are taking a look at different ways that we might be able to do this. And math and cryptography maybe can come to the rescue here for us. As we continue just kind of talking about bridges generally, this slide is showing sort of different types of bridging that can happen. And you notice that, this one has Ethereum and a couple others. Some of them have a whole bunch of support, but we are not really seeing a one-size-fits-all opportunity here. So this is also a pain point that is it's been around recently. Inconsistent user experience in terms of bridging. So for security purposes, actually, sometimes you can bridge one direction very quickly, nice UX, but then going the opposite path is going to be quite a bit longer, actually. So this UX can be pretty confusing, and yes, there are reasons, but for people who aren't super familiar with this, it's just not wonderful user experience. Of course, liquidity has always been kind of an issue for all these different chains launching, and of course, gas token management. I mean, just at ETH Denver, there was a wonderful talk about even just in Ethereum, how estimating gas is very, very difficult. And now we're talking about bridges and relayers and in between dealing with gas token management. So these are all difficult parts of the sort of bridging approach here. Programmable multi-party computation is a really crucial addition. And so we're going to get into this, and I've really dove into this as much as I can. I think I can help explain it. For super nitty-gritty details, come see me after, and I can point you to someone who's much, much smarter than me. So here, we can also talk about maybe the different kinds of approaches. So account-based, we have Near and Lit, for instance, and there's also the deposit-based. I spent some time in Cosmos recently. I'm very familiar with Axelar. That's when you actually deposit some tokens, and then that's the beginning of your journey, essentially. And this is ETH Seoul. I know there's a bunch of blockchains launching, so I do want to talk about how interesting the account system is on Near really quickly. So I have Mike.Near and Mike.Testnet, and unlike Ethereum, where you might have your ENS account, Mike.Near is actually the name of my account, and you can add multiple keys to and from. So if you've heard of EOAs, externally owned accounts, this is sort of built into the protocol. It's a lot more, I would say, interesting and efficient perhaps. And very importantly, this is something that I didn't fully understand how cool it was until I went to a different ecosystem. Mike.testnet has a slot for a smart contract. So you can use it like a regular account where you have a key and you just call smart contracts directly from Mike.testnet. You can also slide a smart contract right in there. So Mike.testnet can also have a smart contract on it. So there's two ways that you could sort of talk to another contract directly, what everyone's used to, or I could even call the smart contract on Mike.near and have that guy do a cross-contract call to another contract. In both cases, it is coming from Mike.near or Mike.testnet. Hopefully that makes sense, but we sort of skipped the whole idea of needing ENS, and I'm very, very excited about ERC 4337 if folks are kind of following that. But that is also like kind of taken care of with Near. Anyway, I think that's really, really, really interesting, and this could come into play for the hackathon as well. So key advantages to the MPC system. So really what's going to happen is we are going to say, I'm starting on Mike.near, and I want to say, what is my address on Arbitrum or Optimism? Or what is my first address on Optimism? What is my second one? You can make all kinds of accounts, essentially, using this MPC service that we have. And what this means also is, back to that slide where we had bridges that were sort of support. It was a subset of all the different chains. If we're using this MPC approach, then it's actually just instant support for any new chains. Small caveat / asterisk here, where right now we have ECDSA support, which is like the vast majority. And then we'll have ED25519 coming as well. And then, of course, standardize the developer experience. Because really all you're doing is you're not having this like bridge where there's like a locker and a minter, but you are literally like getting a signature, and then you just throw that over to whatever RPC on whatever chain you want. It's pretty incredible. Here's a nice little graphic showing us that there's these threshold signatures controlled in this MPC. And so essentially an account like Mike.near will say, I'm going to call, like the method is actually called sign. You're going to give it some interesting information so it is able to determine what my like Arbitrum address is, essentially. And then one by one, these relayers are going to say, okay, Mike just said, please sign this for his first account on Arbitrum. Now we're going to have the different relayers sign, 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 sign. And when you sort of squash those together, it actually generates a signature. It's pretty amazing. A signature meaning that that is just a payload that you can like throw over to the RPC. So this is showing again like any chain that you really want, and then any sort of number here. I think even right now, this is live on testnet right now, and I believe that it's at least 2 to the 32 minus 1, which is like, it's either 3 trillion or it's like 10 or 100 or 1,000 times. It's a very long number that like if you don't have commas, it's almost impossible to tell how big it is, that kind of number. And then, yes, so we're going to call just one method on the smart contract, and it's called sign. And so we're sending over a payload, a path. If you're familiar with what HD paths are, that's essentially it. And again, we are able to call this either directly or have a smart contract call this. We've got some wonderful examples. You don't have to take a picture. This will be in a link tree at the end here. But this is actually going to be an example that you can just run very easily, and you can immediately interact with like testnet Bitcoin, testnet Ethereum. This is really awesome. I'm not sure if everyone's heard of Mintbase, really OGs in the crypto space, and they really like settled down with Near back in 2020 when I first joined, and they've made this really, really cool example that can actually interact with OpenSea testnet NFTs. Like it's quite incredible. I'll have another slide about this later. This is an example that I think is totally worth checking out. They got a lot of the way there. I think that hackathoners might really enjoy this repo. And then also, there's another approach here. I'm not sure if people will have kind of heard about like the decentralized front-end system that Near has been working on. But essentially, like we all enjoy the guarantees of smart contracts. When you are going to move a scary amount of money, you might be able to say, I don't know if I trust that smart contract, but I know the code is here. And if I compile that code, I can compare it. And I can say, yes, for sure, I know like the logic is, the same in this contract that I'm calling. So that guarantee is like really, really useful. So we've actually done this at Near Protocol. It's not just the smart contract, but the button that you press saying like, send a scary amount of money. The button itself, this entire front end, it looks exactly like React, like a React component, but it's stored on chain. So you can inspect the smart contract, you can inspect the front end. Super duper cool. We have an example working here if people want to do that. And then the key derivation. Okay, this is like some pretty amazing things. So I have been thinking for all this time in crypto about like, okay, you have a seed phrase, and then you have a private key, and it resolves to a public key. And so this whole key derivation thing was like a little bit scary to me. I'm like, wait a second, so are all of these relayers just like discovering a private key? That's crazy. It doesn't work like that at all. This is like kind of deep math, and we'll get into this a little bit more. So when these relayers are all signing this message that you instructed them to sign, they are essentially creating this joint signature. And this happens, it's very important. This happens without discovering the private key. And there are a few different approaches. There's like Shamir, secret shares, and all of these different approaches. We are using additive key derivation, and you can find out all about this in the Near docs, docs.near.org. And yes, this will get into all the meat and potatoes. I think if you're a hacker, maybe build first, and then we can dive into the awesomeness later. And just a quick little diagram here. So yeah, you start with the Near account. You're going to send it to sign. And then right now we have sort of a proof of authority kind of system. We're doing the progressive decentralization right now. Again, this is on testnet. These MPC nodes see it. Each of them submit their signatures. And then, now you have all these different addresses here. And talk to us more later about like the validators signing this too. There's quite a bit of interesting stuff that you can do here. This will just be sort of an animation showing an actual this is basically a live demo in terms of how things work. Discovering your Ethereum account based on a particular path, and then you say, I want to send a little bit to that address, and then here's Etherscan saying, boom, it happened. We also have a bunch of Sepolia if people need some testnet ETH. And yes, then there's another amazing video of actually buying OpenSea NFTs, testnet, using this technology. It's really, really incredible. Oh yes, this is what I was hoping I was finding earlier. So this is from the Mint-based example, and it actually, this README goes on longer, but at the very top, you can just run this like super fast, and it's almost like a CLI. It'll prompt you saying, give me your OpenSea testnet bundle, essentially, and provide that example. Now, of course, we have prizes for this hackathon. This is only the first one here, so make sure that you go to the ETH Seoul website and check out the Near Protocol prizes. This is ETH Seoul, so obviously we do want people to like deploy a smart contract onto Ethereum, and then have this chain signatures interact with that in interesting ways, right? Going back to sort of the title of this talk, cross-chain DeFi, I think it would be really, really cool to have someone build like an Ethereum smart contract that's going to, do some basic swaps or something on Ethereum, and your Near account is able to just call that, and you don't have to ever, figure out which MetaMask account you're using or whatever. It's all just kind of controlled already. All right, I think we're kind of ending here. pretty soon. Now, like, stick with me. This is a little bit of a new way of thinking, actually. But this actually works really well if you're trying to like get a mental picture of how you might be able to use this technology for swapping. Okay. Let's say this is a smart contract on Near, and you are an Ethereum master, so you're in the hackathon, and within 4 hours, you've already made your Ethereum smart contract, you've deployed it there. I want to play with Near. Okay, might be the next step. You have a marketplace contract on Near. And remember back at the beginning, I was saying you can call this sign method directly, asking the NPCs to sign it, or a smart contract, yours or whatever you want to write, can also call this sign method. So let's just no one has done this yet, so this is like totally up for grabs. This marketplace contract can essentially derive its own addresses to other chains, right? So that's the important part of holding your head right here. And then we're going to have a simple example of like, you got an ordinal on Bitcoin, let's say, and you got two people that kind of want to exchange. The seller can essentially say, hey, excuse me, marketplace contract, I would like to get a Bitcoin account, but the marketplace contract is the one that sort of is controlling this. So then it might say, okay, the seller is so-and-so, and I have assigned them this one Bitcoin account. Here it is. And then the buyer says, okay, great. I also am interested in like purchasing that ordinal. So then there's communication to the marketplace contract from the buyer. So then the seller says, okay, thank you for telling me my Bitcoin account. I'm going to I have my ordinal on, I'm going to send it to this Bitcoin address that was just derived for me. And then bingo bango, what can actually happen here, and there's a lot of lines here. I think maybe the most important one, I'll get out of the way actually, is this last one, where if this smart contract is controlling sort of an external account on Bitcoin, then you can just say, okay, instead of seller, we're just going to swap. And all of a sudden, like this entire account is now controlled by the buyer. I mean, this would be very simple logic. It's just a mapping, right? It used to belong to this person, gets this address, now it belongs to this person. And so this is a really cool way of sort of doing a hello world swapperoo. So again, this hasn't been built. I think this would be really, really interesting. I got back from a delicious dinner last night and I was like, I want to build this, but I held off because I want to help hackers. So yeah, if you guys want to check this out or even do this example, it would be quite amazing. Again, there are these bounties, and we do want people to, write Solidity smart contract. And then if you have time, I think something like this would be quite amazing. And I will be here, I think, basically for the rest of the day helping hackers. So feel free to come up and find me. Cool. Thanks so much.